What's up everyone, welcome to part 5 of our YOLO tutorial series, and in this one we're going to look at how to train a model to detect an object of our choice. So what you see here is a model that I've trained to detect fidget spinners, and I've got my webcam and my fidget spinner out, and you can see that it's detecting it. It's not detecting it with super high confidence because my model isn't the greatest one, but that's okay. It's going to be a good example, so I'm going to walk you through how to collect data, how to annotate your data, how to train the model, and then to test it. So it's probably going to be broken up in about 3 videos, and in this one we're going to look at how to collect data from online. So let's get started. So before we get into it, I want to point out that in order to get a good model, it's really going to come down to how many images you have, the quality of the images, and how well you annotate them. So if you've only got like less than 100 images and you poorly annotate them, don't expect your model to detect anything. My model here, I trained it on about 250 images. I did take my time and annotate them as best I could. And you can see here that I'm detecting the fidget spinner with 6% confidence, which isn't that great. So I would expect that you would need about 1,000 images in order to get decent confidence, but that's okay. So we're still going to walk through these examples and all the instructions, and if you follow them and collect enough images, you should be able to build a decent model. So with that said, let's jump into the code and see how we can start by collecting images from online. So in order to train a model to detect a custom object, we can break it up into 3 main parts. So the first part is going to be to collect images. So in this video, we're going to look at how to write a script to download images using Google image search. Then we're going to do a little bit of cleanup to get rid of the ones we don't want. And by the end of this video, we'll have a nice data set of images to train with. Then in the next video, we're going to look at how to annotate those images. So each image needs an XML file that says how many objects, where's the bounding boxes, and things like that. So that'll be the next video. And then finally, we're going to look at how to train. So we'll look at the commands, how to train, how to load the model, how to test the model, things like that. So we're looking at about 3 videos for this custom model detection. So now let's get into the code for the first part. So I'm going to begin by creating a new directory in the Darkflow master directory. So I've created this one called new model, and then we've got a new Python file right here. So I've already opened this up in Atom. So let's get started with how to download images from Google. So one note, this code is going to be written using Python 3.6, and because we're using URL lib, you might know that there's a bit of difference between URL lib for Python 2 and for Python 3. So if you're on Python 2, I'd recommend creating a virtual environment so you can work in Python 3.6, but just a warning. So let's get started with the import. So we're going to import OS, and let's go a little bigger. So import OS, and then we're going to import URL lib, and it's going to be URL lib.request. And we're going to import it as ulib just to make our lives a little easier. Then from BS4, we're going to import capital B beautiful soup, and we're going to import it as soup. Next, we're going to import JSON. All right, so now what I'm going to do is create our URL that we're going to use to search for images. So it's a really long string. If you want to, you can copy it, but I'm going to post this code to my GitHub, so I would recommend just referring to the GitHub and copying from there. But I'm just going to copy and paste this. So I've broken the URL up into 4 parts, A, B, C, D. So the first part, I left a curly brace here. So this is where we're going to put our search string. So like fidget spinner, things like that. I also have this other curly brace, which is you're supposed to be able to pass an integer, which represents which page of the search that we're looking for. But what I've noticed is this doesn't work and it always returns the same images. So for each URL when we search, we're going to return 100 images. So this is the string that we're going to use to search, and we just fill in our search string. So once we've got all 4, we're just going to join all of them as a one long string. Cool. So now what we need to do is we need to create this thing called headers. So I'm just going to copy and paste this. So if we're using Chrome, this is what we need to specify for URL lib. If you're using Firefox, it'll be something else, but this is what we need for Chrome. So now what I'm going to do is create a function, and that function is going to be called getLinks. And what we're going to pass is something called the search name. So we're just going to pass what we want to search for. So what we're going to do is we're going to redefine the search name. So we're going to take the search name, and what we're going to do is replace any space that we might have in it and replace it with a plus symbol. So if we search for Fidget space spinner, what we're going to do is replace that space with a plus sign, which is required for doing one of these image searches. Cool. Next, we're going to create something called URL, and URL is going to be URL base, which is just this thing here. And what we're going to do is we're going to format it. So we're just going to format it to place our search name in there. So we'll put search name, and then because we put this here, this other curly brace, I'm just going to pass 0 because it doesn't seem to work if we pass another integer. I thought it would work, but it doesn't. So we'll just put a 0 there. Next, we're going to do is create something called request. And then request is going to be ulib.request. And then we're going to pass the URL, and then none, and then the headers. All right, so the next thing is going to be called JSON string. And then what we're going to do is it's going to be ulib.url open. And what we're going to open is the request, and then we're going to read it. So this will basically open up that URL and read all the contents. Next, we're going to create something called page, and page is going to be json.loads, and then we're going to pass the JSON string. Next thing we're going to do is create something called new soup, and what that's going to be is soup, and then we're going to pass the page, except we're going to strip a little bit off of it, so it's going to be 1 and then what we need to pass is LXML. So soup is going to take that JSON string or that JSON object and convert it into a soup object, which will allow us to quickly pull out the tags that we want. So we'll see how this works in a second. Next thing we're going to do is create something called images, and images is going to be new soup, and we're going to find all, and what we're looking for is all the ones with image tags. So we're looking for all the images in new soup. Next thing we're going to do is create the links, and links is going to be a list comprehension. So we're going to take our image and we're looking for all these sources, and the sources are the actual links. Then it's going to be image. We're looking for the sources for image in images. And then all we need to do is return the links. So now let's see how this works, or see what it returns. So I'm just going to come down, create our if name equals main. Then what I'm going to do is create our search name. So what I'm going to search for is, let's do fidget spinners. Then what I'm going to do is we'll say links is equal to get links, and we'll pass the search name, and then for link in links, let's go ahead and print the link so we can see what this looks like. So I'm going to go ahead and run this, and just a reminder, I'm running this as Python 3.6. So I'm going to pull up my Python 3.6 profile. If you're not sure how to run Atom using different environment or different Python interpreters, I'll link a video above where you can see how to set this up. But I'm just going to run this as my Python 3.6 environment. Now when I run this, you can see I get a whole bunch of links. So each one of these links is a download link to the image. So now that our get links function is working, the next thing we're going to do is create a function to actually download these things. So the next one is going to be called save images, and we're going to pass it links and also the search name. So what we're going to do is create a directory, and that directory is going to be equal to the search name, and we're just going to replace any space in the name with an underscore. That way we don't have any directories with spaces in it. Cool. So if the directory doesn't already exist, we want to create it, and if it does exist, there's no need to create it. So the way we do that is if not os.path.isdir. So if the directory, if it doesn't already exist, what we're going to do is os.makedir, and what we're going to make is the directory. So this will create it if it doesn't exist, and it'll just skip it if it does exist. So the next thing we want to do is for I and image, for I and link in enumerate, and we're going to enumerate the links. So now what we're going to do is create something called the save path. So this is where we're going to save the image. So the save path is going to be os.path.join, and what we're going to join is the directory, and we're going to create the image name, and we're just going to use a integer for it. So we're going to format some integer, and it's going to have 6 digits. It's going to be some 6-digit number. We're going to save these things as a PNG format, and then we're just going to format this and put this I in there. So it's just going to count 0, 1, 2, 3, up and up and up until we save all our images. So finally, that's the save path. So the next thing we need to do is ulib.url retrieve. Then we're just going to retrieve the link, and we're going to place it or save it in the save path. So now let's go ahead and run this and see how it looks. So again, run it with our Py36 profile. Oops, so I actually made a mistake. I forgot to call save images. So what I need to do is, like I said, call save images. So what we can do is get rid of this print statement, and what we'll do is call save images. We're going to pass it links, and we're also going to pass it the search name. So now when I run this, you'll see that I get my folder here, and our images are going to start filling up. There we go. So we've got all our images here. So if I go ahead and pull this up, here's the directory that it creates, and here's all the images that it saves. So it's just a bunch of fidget spinners. Some of them might not be great, like this might not be a good one, or this one, but for the most part, we just get a bunch of fidget spinners. So now, since each search only returns 100 images, what we need to do now is search for a bunch of different search strings. So we'll do, like, say, fidget toy spinner, fidget spinner, fidget spin, just try and do a bunch of different search names to get enough images. So I'm going to go ahead and do that now. All right, so I've gone ahead and ran this 5 times with 5 different search strings. So you can see I've got 5 different directories, all full of images. Now what I want to do is a little bit of cleanup. So the first thing I'm going to do is move all of them from 5 different directories and consolidate them into one single directory. So in order to do that, I'm going to go ahead and create a new file. So new file, I'm just going to call it rename os.py. So with this one, like I said, we're going to move all of them into one directory. So in order to do that, this one's going to be pretty straightforward. So we're just going to import os, and then we're going to create something called imagdir or imdir, and this one's just going to be called images. And then what we're going to do is create a folder called images. So if not os.path.isdir, so if this path or this directory doesn't exist, what we're going to do is os.makedir. So just create this imdir if it doesn't exist. Next thing we're going to do is we're going to create a list of all the folders that have images in it. And if you recall, all of them have the name Fidget in it. So we can use this to create a list of all these folders. So what we'll do is call this thing Fidget folders, and it's going to be a list comprehension. So it's going to be folder for folder in os.lister. So what lister does is list all the directories in some path we give it. So since this rename.py is in the current working directory with all those folders, we can just say dot. So that means look in the current working directory. And so we're going to get everything in the current working directory, but we don't want everything. We just want the things that have Fidget in the name. So if Fidget in folder. Cool. So that's all we need. This will just give us all the folders with Fidget in it. And just to prove it, why don't I go ahead and print the Fidget folders. So let's go ahead and run that. So yeah, we can see Fidget Kid Spinners, Fidget Kid Spinner Toys, Fidget Spinner, Fidget Spinners. Yeah, so that's all of them. Now what we want to do is we want to move all of them into that new folder and rename them. So I'm going to create a counter called n, and then what we're going to do is for folder in Fidget folders, so we're going to loop over the folders, then we're going to loop over everything in there. So for the image file or im file in os.skander. So skander is a function that's a lot like lister, except it has a lot more features. So I'll show you how this works in a second, but we're just going to pass the path. So our path is going to be the actual folder. Next thing we're going to do is os.rename. So what rename does is you pass it the path to the object that you want to rename, and then you pass it the path to where you want to save it or where you want to rename it. So where is everything located? So we're going to take the file or the image file.path, and then we're going to move it to os.path.join. And where are we going to put it? We're going to put it in our image dir, and then we're going to rename it, and we're going to use the same naming convention. So it's just going to be some number that has 6 digits, and the extension is going to be PNG, and then we're going to format it, and we're just going to pass in n. So n is just going to be some counter, so we need to increment n. So n is going to be plus equals 1. So this should work. Let's go ahead and run this, see what we get. And then if I pull up my new model, you can see we've got this new folder called images, and this should have everything in it. So this is all of the images that we want. So now that we've got all our images consolidated into one folder, now what we want to do is do a little bit of visual inspection and try and pick out some of the images that won't be good. So for example, like this one here, this one's like some x-ray with some kid with a fidget spinner in his throat. So there's no need to keep this one. There's really nothing in there to train with. It's not a good image of a fidget spinner, so we'll delete that. Some of the other ones, like this one, I don't see it. Some kid getting arrested. We don't need that. So just go through all the images and try and pick out the ones that don't make sense. Like here's another x-ray of some kid who swallowed a fidget spinner, but yeah, so we need to do some manual cleanup. Although some of these fidget spinners don't really look like fidget spinners, so like maybe this one's not a great example, or this thing right here. So we want to look for ones that are good representations of fidget spinners. If they're too dynamic, or some of these weird ones like this dollar sign, this might not be a good one to train on. But yeah, so use your judgment, go through and visually inspect them, and just get rid of the ones that are like totally unrelated or might not be good example images. So once you've done that, we're ready to proceed. So I'm going to call it quits for this video, and in the next one we're going to look at how to annotate our images, and also how to do this in a fast way, or try and automate the process as best we can. So we're going to show the image, and we will be able to draw bounding boxes around it, and then click one button, and that will save our annotation file. So that's gonna be the next one. Again, the code's gonna be posted to my GitHub, so you can download it and reference it there. If you've got any questions, feel free to leave a comment below, or contact me in the Facebook group to chat more. I know we're going through this kind of fast, but there's a lot to cover, and yeah, code will be available. I'm available for chat. So thanks guys. Thanks for all the likes and support, and I'll see you guys in the next one.